When electrophilic substitution reaction occurs in pyridine, at that time we have three different positions where electrophile may enter, and for that purpose let me write the numbering. So this is 1, 2, 3, 4, 5 and 6. Here the electrophile may enter at position 2, at 3 and 4. Now in this video we have to check out of these three positions which position is more predominant. When we do the electrophilic substitution at position 2, so we can write the resonating structure like that. Here you can see that the electrophile will come at position number 2. The lone pair of electron is present on this nitrogen. The other bonds will remain as it is, and the positive charge will come on the carbon number 3. This positive charge get delocalized into ring in this fashion, and now this charge shift from carbon number 3 to carbon number 5 in the next resonating structure. So we may write the next resonating structure like that. So lone pair of electron which is present on this nitrogen will remain as it is. The electrophile is present at position 2. The other bonds will remain as it is like that. And now here we have double bond between these 3 and 4, and positive charge will come on this carbon. Now this positive charge we can delocalize in this way, and we can write the next resonating structure. In next resonating structure, again the lone pair of electron will remain as it is on this nitrogen. This electrophile is present at position 2. The other bonds, such as the bond between this carbon number 3 and 4, and here we will have the newly formed bond between this carbon number 5 and 6. The interesting part is this double bond will get delocalized on this nitrogen. So this is little bit interesting that on the electron rich species like nitrogen we have positive charge in resonating structure. Now let us write the resonating structures when we do the electrophilic substitution at position 3. So we can write the structure like that. Here we have electrophile at position 3. The lone pair of electron is present on this nitrogen. The other bonds will remain as it is like that. So you can see here, and the positive charge will come on this carbon 2. So this positive charge will get delocalized in this fashion in the next resonating structure like that. So we have next resonating structure. So here in this case you can see the electrophile is at position number 3. The lone pair of electron is present on this nitrogen. The other bonds will remain as it is. So this bond will remain as it is, and here we'll have the newly formed bond between this nitrogen and carbon, and this positive charge will transfer from carbon number 2 to 6. Again this positive charge get delocalized into the ring, and we may have the next resonating structure like that. So negative charge will be on this nitrogen, and we have electrophile at position number 3. The other bonds will remain as it is, so this bond will remain as it is, and we have new bond between this carbon 5 and 6, and we have positive charge on this carbon 4. Here you can see that there is no positive charge on nitrogen in all these three resonating structure. Now let us write the resonating structure when we do the electrophilic substitution at position 4. So the resonating structure will be like that. So in this case we have to write down the lone pair of electron on this nitrogen and the electrophile on position 4. The other bonds will be as it is. So this bond will remain as it is, double bond, and this bond will remain as it is. Here in this structure, the positive charge will be on carbon number 5, and this positive charge will get delocalized in this fashion, and we can write the next resonating structure like that. Now in this structure you can see that the lone pair of electron which is present on nitrogen will be there, and we have electrophile at position number 4. The other bonds will be on the same position like this, and here you can see this positive charge will get delocalized on this nitrogen. So we must write positive charge on this nitrogen. This is the new bond, and this is the positive charge on this nitrogen. In this resonating structure also we have positive charge on this nitrogen. Again this positive charge get delocalized in this fashion, and we may write the next resonating structure like that. So here on this nitrogen we have lone pair of electron. At position 4 we have electrophile. The other bonds will be as it is, and this will be the new bond between this nitrogen and the carbon, and the positive charge will come on this carbon number 3. If you see these three positions and the resonating structures corresponding to it, at that time we'll find one important thing, that in this resonating structure when we do the electrophilic substitution at position 2, we have positive charge on this nitrogen. You can see carefully. But in this all three resonating structure we don't have any positive charge on this nitrogen. Here also in this case we have positive charge on this nitrogen. It means that when we do the electrophilic substitution at position 2 as well as 4, at that time these two positions are little bit unstable, and the position number 3 is more predominant position when we do the electrophilic substitution reaction. This means that the electrophile will come predominantly at position number 3.